question number 34. The number of different permutations of all the letters of the word permutation such that any two consecutive letters in the arrangement are neither both vowels nor both identical. He has given us a peculiar type of restriction on the letters of the word given. The options available are, the first option is 63 into 6 factorial into 5 factorial. Second option is 57 into 5 factorial into 5 factorial. The third option is 33 into 6 factorial into 5 factorial. And the fourth option, that is option D, is 7 into 7 factorial into 5 factorial. Let us examine. What is the given word actually? The given word actually is permutation. What are the vowels here? E, U, A, I, O. All the 5 vowels of the English alphabet are involved here. This is a peculiar word. He has asked us to find the number of permutations in which no two adjacent letters, two consecutive letters should not be neither both vowels or both identical. So what should have? No two vowels come together and identical letters. How many identical letters are there actually? T and T. They are the only two identical letters, yes, of course. That is, we want to have no two vowels should come together and the two T's should not come together. The two T's should not come together. Let us find them. What are the letters? Letters the letters different from the vowels. What are they? P, R, M, T, T, N. How many are they in number? 6. How many are they in number? 6. This can be arranged in 6 factorial by 6 factorial by 2 factorial. 2 factorial. Among these, how many gaps will be there? 1, 2, 3, 4, 5, 6, 7. How many? 7 gaps will be there. Out of these 7 gaps, how many vowels are to be present here? 5 vowels are to be arranged. How many? 5. So, answer is vowels. 7P, 5. 7 possible places are there and 5 vowels are there. So, the answer is 7P5. Therefore, in total 6 factorial by 2 factorial into 7P5 is the right answer. What is this answer? This is the answer. This is the answer in which no two vowels come together. So far we could have followed one restriction among the given restrictions. The other restriction is also there. What is the other restriction? No two adjacent are identical. And the only identical pairs here is T and T. T and T. Therefore, we are now ready to find the number of those arrangements in which these two T's do not come together. These two T's do not come together. Do not come together. That can be had by taking total minus coming together. Now, we find those permutations in which these two T's come together. How can you find? We shall find it in due course. Let us remember this answer. 6 factorial by 2 factorial into 7P5. This is the total number of arrangements. From this, we are now ready to subtract those arrangements in which the two identical letters are together. Now we find those permutations in which those two T's come together. How to find them? P, R, M, T, N. We like to find the permutations in which these two T's come together. That is, I am clubbing those two T's as a block or box to consider them as one unit. Now, how many gaps will be there? 1, 2, 3, 4, 5, 6. First of all, these letters will be arranged in 1, 2, 3, 4, 5. 5 factorial into. How many gaps are there? 6 gaps are there. It is 6p5. 5 vowels. This is the number of permutations in which no two vowels come together and both the T's come together. The previous answer is the total number of permutations in which no two vowels come together. That was 6 factorial by 2 factorial into 7p5, and this is now 5 factorial into 6p5. This is total minus negation idea. So in these permutations we have no two vowels come together and no two T's come together. So that is, no two adjacent letters are vowels and no two adjacent letters are identical also. Of course, the identical pair is only one pair, that is TT, and they do not come together because we could have subtracted all such things from the total. So this is the required answer, and if you are able to get it simplified, you will observe that the second option is the right option, that is 57 into 5 factorial into 5 factorial. The option B is the right option here. The immediate question before us is question number 35. The least positive integral value of x which satisfies the inequality 10cx minus 1 is greater than 2 into 10cx is. X is positive, of course. He has given us the restriction, and the least such x that can satisfy the given inequality. What is the given inequality? 10cx minus 1 is greater than 2 into 10cx. X is of course supposed to be positive. Here, two things you have to observe. Number one, x minus 1 less than or equal to 10. Observing this, therefore x less than or equal to 11. One more, x less than or equal to 10 also. These are the things that you can read immediately by looking at those coefficients 10cx minus 1 and 10cx. Moreover, beyond that, we shall now make use of this inequality like this. 2 into 10cx is less than 10cx minus 1. Implies 2 into 10cx by 10cx minus 1 is less than 1. 2 into 10cx by 10cx minus 1 is less than 1. Or even you can have by 2. But we have had a beautiful formula for NCR by NCR minus 1. Let us recollect that. What is the formula which we could have already have? NCR by NCR minus 1 is therefore N minus R plus 1 by R. Making use of this formula, making use of that formula, you can write this as 10 minus x plus 1 by x is less than half. What is 10 minus 10 plus 1? 11. 11 minus x by x. 11 minus x by x is less than half. Let us cross multiply that. As x is positive, it can be possible. Therefore, 22 minus 2x is less than x. Therefore, 22 is less than 3x, or 3x is greater than 22. That is, x is greater than 22 by 3. But 22 by 3 is 7 point something. 7 point something, x is greater than that. Therefore, x is greater than or equal to 8. X is greater than or equal to 8. So, value of x might be 8, 9 or at most 10, as x is less than or equal to 10. Among all of them, what is the least value of x? 8. Therefore, least value of x is the least value of x is 8. 8 is the right option. That is option 2. That is the second option is the right option. Answer is 8. That is the least positive integral value of x is 8. Therefore, the option 2, the option B is the right option. In this question, the number of onto functions which are non-decreasing from the set 1, 2, 3, 4, 5 and the set containing 7, 8, 9 is required. In the first option, he has given it to be 5. In the second option, that is option B, it is 6. Option C, it is 10. Option D, none. Let us now have a look over that. What do you want to require actually here? A and B are two different sets. A contains the elements 1, 2, 3, 4, 5 and B contains the elements 7, 8, 9. And we require onto functions. What is A actually? 1, 2, 3, 4, 5. What is B? 7, 8, 9. What is the set B? 7, 8, 9. I am defining a function, you observe. 1, 1. Is it onto or not? In order to answer this question perfectly, we must have enough command over the two words. Number 1, non-decreasing function, and number 2, onto function. Let us first of all recall the definition of an onto function. What is the codomain here? 7, 8, 9. What is the range here? 7, 8, 9. That function for which the codomain coincides with the range is just nothing but an onto function. Therefore, the function which we look at on the board is of course an onto function. Therefore, no element in the codomain must be left behind vacant or empty without having any pre-image. That is a character of an onto function. By the by, what is a non-decreasing function? What is a non-decreasing function? If there is a function, say f x1 less than x2 implies f of x1 less than f of x2. That is the character of a strictly increasing function equal to f of x2. That is the character of a non-decreasing function. If you draw the graph of a non-decreasing function, it looks like this. If you can draw a graph to a perfectly increasing, strictly increasing function, it looks like this. That's all the difference between the two words, strictly increasing and non-decreasing. Yes, let us test. Let us examine whether the function which we have defined, we could have defined here, is non-decreasing or not. 3 is less than 4, but f of 3 is equal to f of 4. 1 is less than 2. F of 1, 7. F of 2, 8. It is less than. F of 1 is less than f of 2. So, that definition is absolutely followed here. This is a non-decreasing function. No doubt about it. Well, what is the question? What is the actual question here? How many such functions do exist here? That we want to find. Let us try to find it now. So, after recalling the definition of a non-decreasing function, we are now proceeding to find the number of onto functions. You please observe this. Here, this has one pre-image, three pre-images. Let us now observe the different cases. Now, one pre-image, three pre-images, one image. Another. How? F of 1 is 7, F of 2 is 8, F of 3 is 8, F of 4 is 8, F of 5 is 9. Of course, we can manage the definition so that it is non-decreasing by keeping this in view. What do you mean by this type of arrangement? One pre-image, F of 1 is 7. Three pre-images, F of 2 is 8, F of 3 is 8, F of 4 is 8 and F of 5 is 9. Yes, the definition of a non-decreasing function has been followed here. Well, another case. Two pre-images, one pre-image, two pre-images. That may happen. What will be the definition? F of 1 is 7, F of 2 is 7, F of 3 is 8, F of 4 is 9, F of 5 is 9. Two elements come here, one element come here, two elements come here. Another, 2, 2, 1. 2, 2, 1. That may happen. How? Two elements have having been mapped to 7. F of 1 is 7, F of 2 is 7. F of 3 is 8, F of 4 is 8. F of 5 is 9. 2, 2, 1. And then 3, 1, 1. 3, 1, 1. What is that? F of 1 is 7, F of 2 is 7, F of 3 is 7, and F of 4 is 8, F of 5 is 9. Like that. 1, 1, 3, 1, 3, 1, 3, 1, 1, 2, 1, 2, 2, 2, 1, and again one thing is missed here. 1, 2, 2. That might also happen. What is the definition with that combination? F of 1 is 7, F of 2 is 8, F of 3 is 8, F of 4 is 9, F of 5 is 9. Altogether, how many such combinations are possible? 6 functions are possible. Therefore, what is the right option? Option B is the right option. There are 6 onto functions that are possible to be defined, which are of course non-decreasing. Yes. So, this type of distribution, you may have to get a plan according to that, so that you will be having the number of onto functions directly. Hence, the answer is 6. That is option B. The next question. Let us look at the next question, that is question number 37. The number of ways in which 30 coins of 1 rupee each be given to 6 persons so that none of them receives less than 4 rupees is. 30 coins are there with me. Each coin is a rupee coin. 30 coins are there. And these are supposed to be distributed among 6 persons. Of course, so that none of them receives less than 4 rupees. That is, at least every one of the persons should receive not less than 4 rupees. That is 4 coins. The number of ways to distribute this is required. How to get it? How many coins are there? 30 coins are there. How many persons are there? 6 persons are there. Let me name them. X1, X2, X3, X4, X5, X6. Let me name those persons as X1, X2, X3, X4, X5 and X6. How many coins are there with me? 30. Minimum number of coins that must be possessed by each individual. How much? 4. So let us do firstly one thing. Let me give 4 coins, 4 coins, 4 coins, 4 coins, 4 coins, 4 coins to each of them. So minimum requirement has been fulfilled so far. if you distribute 4 coins to each of those 6 persons, how many coins have been expended? 24 coins have been expended. Still, how many coins are with you? 6 coins are with you. 6 coins are with you. So, let me now redesignate x1, x2, x3, x4, x5, xn 6 as the number of coins that can be distributed to the 6 respective persons. Okay, already each of these 6 persons have got 4 coins. Thereby, the so-called minimum requirement, the minimum condition has been already satisfied. Now again 6 coins are there with us. They are to be distributed among those 6 persons. Now, what do you want to have? Do you want to have the non-negative solutions or positive integral solutions for this equation? Positive integral solutions or non-negative integral solutions we should have. We should have non-negative integral solutions of this equation we are supposed to have, and that can be estimated by a famous formula or format n plus r minus 1 c r minus 1. N plus r minus 1 c r minus 1. What is that? 6 plus 6 minus 1 c 6 minus 1. See? 6 minus 1. Therefore, this is nothing but number of non-negative solutions is equal to 6 plus 6 minus 1, c 6 minus 1. What is 6 plus 6? 12. 12 minus 1 is 11. 11 c 5. 11 c 5. Let us now calculate what 11C5 is. It is nothing but 11 into 10 into 9 into 8 into 7 by 5 factorial, that is 120. 120. 9 8s are 72. This is 720. This 720 in 120, it goes 6 times. So that 6 7s are 42 and 42 11s are 462. 462. What is the right option? Option B is the right option. That is the second option. Answer is 462. The basic idea here that one must possess is there has been a minimum requirement to each of the persons. Let us first fulfill that minimum requirement. That is by distributing 4 coins each in the beginning itself, so that 24 coins have been expended in the beginning itself. So the remaining 6 coins, they are supposed to be distributed among the 6 persons available, and that problem can be compared with the number of non-negative integral solutions of the equation x1 plus x2 plus x3 plus x4 plus x5 plus x6 is equal to 6, which can be expressed by using the formula n plus r minus 1 c r minus 1. There is 11c5, which gives the answer as 462. That is the right option. Second option, that is B. The next question is before us. That is question number 38. The total number of even divisors of 1,89,000 that are divisible by 15. One more condition has been put forth here. Here 2 restrictions are to be kept in mind. Number 1, you are supposed to have even divisors. Number 2, they must all be divisible by 15. Let us see. First of all, the canonical form of 1,89,000. That is the normal form. That is nothing but a prime factor representation of a natural number is just nothing but called a canonical form. Let us recall the meaning and establish that on the board. What is 1,89,000? It is 189 into 1000. 1 plus 8 plus 9 is divisible by 9. Hence 9 is a factor here. This is 9 into 21 into 1000. 9 is nothing but 3 square. 21 is nothing but 3 into 7. 10 cube is nothing but 2 into 5. All together, how many prime numbers are here? How many 2's are there? 2 cube. How many 3's are there? 3 square into 3. 3 cube. How many 5's are there? 5 cube. How many 7's? 7 power 1, that is only 1 7 is available. Prime number, prime number, prime number, prime number. These are the distinct prime factors. What are the distinct prime factors here? 2, 3, 5, 7. 2, 3, 5, 7. 2, 3, 5, 7. Yes. What type of numbers do we like to have? What type of numbers do we like to have? We like to have even divisors, okay, 2 squares, 2 cubes, any one of them must be present. Next, divisible by 15. What is 15? 3 into 5. At least 1 3 and at least 1 5 must be present. Okay, so far at least 1 2, at least 1 3, at least 1 5 must be present among the required divisors, that is sure. Then what about 7? It may or may not be present. May or may not be present. Okay. What is the required number of divisors? Required number of divisors is is equal to 1 2 may occur, 2 2's may occur, 3 2's may occur. So regarding 2's, how many ways of selection are there? 3 ways of selection are there. Regarding 3's, 3. Regarding 5, 3. Regarding 7, it may occur, it may not occur. How many cases? 2 cases are there. Into 2. What is the total number of such divisors? 3 into 3 into 3 into 2. What is that? 27 into 2. How much? 54 is the answer. Therefore, what is the total number of even divisors that are divisible by 15? Is nothing but 54. That is, second option is the right option. Option B, that is 54, is the right option for this question. The next question before us is question number 39. What is the question here? An n-digit number is a positive integer with exactly n digits. 900 distinct n-digit numbers are to be formed by using the digits 2, 5 and 7 only. You follow the restriction very carefully. How many digits are there to be used? 2, 5 and 7 only. The smallest value of n for which this is possible is first option 6, second option 7, third option 8, fourth option 9, option A is 6, option B is 7, option C is 8 and option D is 9. Let us first of all understand the question very carefully. How many digit number we require? N digit number we require. 1, 2, 3, 4, 5, 6, 7 and so on, n. Let us view the format of an n-digit number. An n-digit number is going to be formed now. That is, we are supposed to fill n gaps with how many digits? 2's, 5's and 7's. That's all. Okay. the first place can be filled in. The first place can be filled in. How many ways? By 2, by 5, or by 7. How many ways? 3 ways only. Similarly, the second place, 3 ways. Again, the third place, 3 ways. The fourth place, 3 ways. The fifth place, 3 ways. Sixth place, 3 ways, and so on. If you proceed like that, even up to n places, the last place could also be filled in 3 ways. Therefore, total number of numbers is total number of such numbers is 3 into 3 into 3 into 3. How many times? N times. So how many such numbers will be there? 3 power n. Now let us think of the question. That is a requirement. What has been required in the question? He is asking us the least value. Which least value? Which type of least value we require? Let us understand. 900 distinct n-digit numbers are to be formed by using digits 2, 5, 7. So, the total number of such numbers must be greater than or equal to 900. Greater than or equal to 900. Now you think of the least value of n for which it happens is 3 square is 9, 3 cube is 27, 81, 243, 729 and 2187. Therefore, 3 power n, if it is to cross 900, what is the minimum value of n? It must be 7. Why? Because 3 power 6 we know that is 729 itself. It is not exceeding 900. Even if you have 3 power 6, it is just 729 only. But we have to cross 900, isn't it? Therefore, the minimum value of n for which this happens is 7. The least value of n is 7. The least value of n is 7, hence the correct option is the second option, that is 7. Option B is the right option. Answer is 7. Let us make a move to go through the next question, that is question number 40. The number of integral solutions of the equation x1, x2, x3, x4, x5, x1 into x2 into x3 into x4 into x5 is 2310. Is the number of integral solutions of that equation is. He has said integral solutions only. He has not mentioned non-negative integral solutions or positive integral solutions. Such type of words have been not included in the question. He has just asked to have the number of integral solutions only. You have to keep that in mind. Of course, they are integers, they must be integers. Some of them might be negative, we do not mind. Of course, the product must be positive. What is the product? 2310. In order to keep that positive, you can take some of those factors might be negative. I do not mind at all. Product must be positive, that is 2310. Let us now observe the canonical form of the 2310. What is that? What is the given number? 2310. This is 231 into 10 in the beginning. Okay. 2 plus 3 plus 1 is 6. It is divisible by 3. Hence 3 must be a factor here. This is equal to 3 into 7 3s are 21, 7 3s are 21 into 10. So that this is 3 into 7 into 11 into 2 into 5. Let us form them in a particular order. 2 into 3 into 5 into 7 into 11. How many prime factors are there? 5 prime factors are there. These five can be placed in 5 places in how many ways? 5 to the power of 5 ways. 5 to the power of 5s, provided if you take all of them positive. All of them positive. Besides that, there might be two more cases also there. There might be two more cases. What are the cases? 3 of them might be positive and 2 of them might be negative. Another case is 4 of them might be negative and 1 of them might be positive. If 2 of them are negative, product is positive. If 4 of them are negative, then also the product is positive. So those 2 more cases are also there, right? So if 2 of them are negative and 3 of them are positive, how many ways we can select them? 5C2 into 5 power 5. 2 of them are negative, so their product is positive. That case may happen. And then one more case is also there. What is that case? 4 of them might be negative. 4 of them might be negative and 1 is positive. Out of those 5 which are to be negative, you can choose in 5C4s. Hence, the answer will be 5C4 into 5 power 5. Now, you add all of them. 5 power 5 into 1 plus 10. 5C2 is 10. 5C4 is, what is 5C4? 5C4 is nothing but 5C1 and it is 5. Therefore, 1 plus 10 plus 5 becomes 16 into 5 to the power of 5. Is the answer available? Of course it is available. In which option? The third option, that is option C, is the correct option. And the correct answer is 16 into 5 to the power of 5. 16 into 5 to the power of 5 is the right option. That is option C. This is our turn to go through the next question. That is question number 41. A delegation of 4 students is to be selected from a total of 12 students. Number of ways in which the delegation be selected if 2 particular students refuse to be together and 2 other particular students wish to be together. Only is it's a beautiful question. What is the total number of students? 12 students are there. A delegation of 4 students is to be formed. First of all, you must understand, is it a combination or a permutation? You are supposed to select 4 students, that's all. Yes. That is, you are supposed to form a committee of 4. A team of 4 students. A team of 4 students is to be formed. What is the restriction here? There are 2 particular students, say A and B. They'll always like to be together. They like to work together in a team. If A is there, then B also wish to work with that. Similarly, there are 2 more friends, C and D. They do not like to work together. If C is in the committee, then D refuses to join in the committee. Similarly, if D is in the committee, then C refuses to join in that committee. That is the peculiarity of those 2 students, C and D. Keeping all these things in our mind, we are supposed to have the committee, the number of ways in which we can frame the committee. There are different cases. Let us now observe all those cases. What is the total number of students? 12. Let me consider the first case as A and B are only selected in the committee. A and B are only selected. Okay. Let me name those students first of all. Let A comma B like to be together. And let C comma D do not like to be together. To be together. And we are supposed to select 4 out of those 12, among which these A, B and C, D are also members, among which A, B, C and D are also members. Let us now discuss with the different cases of selection. Number 1. A, B are only selected. What does it imply? Total number 12. Already selected 2. Still you have to select 2. Okay. A and B are only selected. What does it mean? C and D are not selected. Out of the remaining 2, you delete those 2. What is the remaining number of students? 8. Out of those 8, you are supposed to select 2. How many ways? 8C2. That is 8C2. 8 into 7 by 2. That is, okay, we shall think of that later. A and B are only selected. It means C and D are not selected. Deleting these 4 from the 12, 8 persons are there. Out of those 8 students, you are to choose 2. Why? Because the committee should comprise 4 students. 2 students are already here, 2 students there. Next case, A, B, C are only selected. 3 students are already selected. Only selected. What does it mean? D is not going to be selected. So from those 12, you omit A, B, C because they are already selected, and D also. Remaining 8. Out of those 8, how many are required in the committee? There is only 1. Therefore, 8C1. A, B, D are only selected. Again the same discussion, then answer is 8C1. A, B, D are already selected. Next case, C is only selected. What does it mean? C is only selected means A and B are not selected. And we are not supposed to select D because C and D do not like to work together. Therefore, out of 12 members, you first omit C because he is already selected. Next omit A and B because they are not selected. Omit D also because it is not to be selected. So omit 4. From the remaining 8, how many people are required? 3. Why? Because the committee should comprise 4 students. And then D is only selected. D is only selected. In this also, what is the, similar to this case, what is the total number of selections? 8C3. Next. And the last, none of A, B, C, D is selected. That also may happen. Why should we take interest on A, B, C and D? Because they are putting some restriction. That case must also be there. What happens then? What is the total number of students? 12. You are supposed to omit 4. Omit them. Remaining 8. From the remaining 8, how many are required now? 4. Full 4 members of the committee. How many ways you can do? 8C4. Now you add all of these things. What is 8C2? 8 into 7 by 2 into 1. 28. 8C1. 8. 8C1. 8. What is 8C3? 8 into 7 into 6 by 3 factorial, that is 56. This is again 56. And 8C4. What is 8C4? 8 into 7 into 6 into 5 by 4 factorial, that is 70. 70. If you add all of these things, you are going to get 226. You add them. 6 plus 6, 12, 20, 28, 36. 10, 20, 22. That's all. 226. So what is the total number of ways of forming that delegation? That is, number of committees comprising 4 students with the restrictions given. This is the way of selecting those. What is the right answer? 226. That is, the right option is the second option, option B. Answer is 226. Now the next question before us is question number 42. What is there in this question? The total number of ways in which 3 distinct numbers in AP can be found from the set containing the natural numbers 1, 2, 3, 4, etc. up to 24 is. What is required here? You are supposed to choose 3 natural numbers. Say A, B and C. What type of natural numbers you require? They must be distinct and they must be in AP. They must be in AP. So, how can we choose them? Let us have a check. The first option, that is option A, is 66, option B is 132, option C is 198, option D none. Let us examine which option is the right option. Well, what is the set given? 1, 2, 3, 4, etc. 24. 24. Okay, let them be A, B, C. Let A, B, C be in AP. So, as they are in AP, we say that A plus C is equal to 2B. A plus C is equal to 2B. What is 2B? It is even. Is even. Is even. A plus C is even. Implies A plus C is even. So A plus C, the sum of 2 natural numbers is even. How many cases does will arise there? Number 1, both A and C might be even. Both A and C might be odd. Isn't it? Implies both A and B are even, or both A and B are odd. How can we choose them? From 1 and 24, how many even numbers are possible? 12. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 20 and 24. They are 12 in number. Out of those 12, you are supposed to choose 2. How can you choose 12 C 2 ways? Suppose you have chosen 4 and 6. What will be? 5. If you can choose 2 and 20, what will be? 11. So, by the selection of A and C, B will be fixed. So, the number of ways you can choose A and C gives you the triplet ABC. Yes, of course. Okay, you can choose both odd integers. How many ways? 12C2. What is the total number of ways of selecting? This is 12C2 plus 12C2. Is it plus or into? Recollect the fundamental principle of counting. Recollect them. Are these 2 things happening at a time? At least one of the things, or exactly one of the things? At least one of the things. Therefore, you are supposed to add them. What is 12C2? 12 into 11 by 2, that is 66. Again, that is 66. 66 plus 66 is, of course, 132. What is the answer? 132 is, of course, the right answer. Is the right answer. We are supposed to choose. Okay. So, option is 132. That is option B is the right option. We can approach this problem. We can approach this problem in a different way also. Let me try to explain that method also to have the answer here. The style of getting the answer for the same question. We are supposed to choose 3 numbers, 3 natural numbers from 1 and 24. Which type of natural numbers do you require? They must be in AP. AP means there must be some difference. Can that difference become 0? No. Why? Because those 3 must be distinct. He is saying the total number of ways in which 3 distinct numbers in AP can be formed. Therefore, the difference can be 1. If the difference is 1, how can you select 3 numbers? 1, 2, 3, 2, 3, 4, 3, 4, 5, like that. 28, no, 24 is the last one. As the last one is 24, 22, 23, 24. So, with the difference 1, how many triplets you have? 22 ways you can choose. If the difference is 2, what happens? Then 1, 3, 5, 2, 4, 6, 3, 5, 7, and so on. 20, 22, 24. How many are these in number? 20. If the difference is 3, what happens? 1, 4, 7, 2, 5, 8, 3, 6, 9, and so on. 18, 21, 24, etc., etc., etc. Difference can be any. Therefore, what is the total number of such numbers? Here it is 22. Here it is 20. And then 18. And then 16. Up to what place you can move? Up to 2 only. This is the total number of such numbers. Now you add all of them. You take 2 as a common factor. 2 into 1 plus 2 plus 3 plus etc. 11. This is 2 into 11 into 11 plus 1 by 2. It is nothing but 11 into 12. What is 11 into 12? It is nothing but 132. This is another way of making an attack on the question. We just want to have 3 numbers which are in AP. AP means there must be maintained some difference. That difference can be 1, 2, 3 or like that. You proceed like that, you will be able to estimate the number of such combinations. The answer is 132. In any method you can follow. The answer is option B, that is 132. The next question before us is question number 43. It is an interesting question. The number of polynomials of the form x cube plus ax square plus bx plus c that are divisible by x square plus 1, where a, b, c are natural numbers from 1 and 10. A, b, c belong to the set containing 1, 2, 3, etc., etc., 10. How many such polynomials will exist which are divisible by x square plus 1? We are supposed to find out. The first option is option A is 10, option B is 15, option C is 5, and option D is 8. Let us have a look over that. What is the given polynomial? X cube plus ax square plus bx plus c. What are ABC? Natural numbers. What type of natural numbers? What type of natural numbers? A, B, C belong to the set containing 1, 2, etc., 10. This is the data. Another constraint, rather condition, has also been given. What is that condition? That polynomial x cube plus ax square plus bx plus c must be divisible by x square plus 1, he is saying. Let us observe that case. When can that polynomial be divisible by x square plus 1? Let us check. Divide it with x square plus 1. X times x cube plus x, subtract ax square plus x into b minus 1 plus c. Again, this is ax square, this is x square. A times ax square plus a, subtract. What are you going to have? X into b minus 1 plus c minus a. this is the situation when this polynomial is divided by x square plus 1. But the required condition is the polynomial must be divisible by x square plus 1. For that, what is required? The remainder must vanish. The remainder must be 0. Isn't it? Therefore, we proceed according to that. Now, x square plus 1 is a factor. X square plus 1 must be a factor. That is, it must be, the polynomial must be divisible by x square plus 1. Implies remainder is 0. What should happen? Remainder must be 0. What is the remainder? X into b minus 1 plus c minus a. For that, implies what should we require? B minus 1 is equal to 0 and c minus a is equal to 0. Isn't it? Yes, of course. So, b is equal to 1 and a is equal to c. Now, follow this result. In order that this is divisible by x square plus 1, what are all the things that we must possess in our hand? B is 1. No question of selection, it is fixed. B is 1. And a is equal to c must be selected. If you select a, it means that c has been selected. So, either a or c can be selected from what is the set given? A, B, C belong to. From which set you are supposed to select both A, B and C? From this collection. Now, we are to select A and C only. In fact, A only. If you can choose A, it means that you have selected C also, because A is equal to C. Well, how many ways can you choose A from this collection? 10 ways. Therefore, number of ways is equal to 10. Is equal to 10. What is the right option? Option A is the right option among the given. So, right answer is 10 and the right option is A. A is the right option.